So now that we've seen that functions are objects in JavaScript, we're going to see how the JavaScript programming language lets us do some really interesting and powerful things with this concept, the concept of first-class functions. To start, we need to understand the difference and the usage of function statements and function expressions. Well, that sounds complicated. It isn't. Big word alert. An expression. An expression is a unit of code that results in a value. And that's it. So when we say a function statement, statements just do work. But a function expression, or any expression in JavaScript, ends up creating a value. And that value doesn't necessarily have to save inside a variable. All right, let's look at an example. So I have my empty app.js file, and I'm just going to declare a variable. Well, let's just say A. Then I'm going to run this, and I'll open the console here in Google Chrome. And now I have A sitting there in memory, and I can write some code on the fly here in the console. So what is an expression? You said an expression returns a value. So I have a unit of code, some code that I've written, and that unit, essentially a line of code, although it can be split into multiple physical lines, sometimes it's run as a unit. I have a unit of code. I'm setting A equal to 3. Remember that equals is an operator, a function that takes these two values, does some work, and then returns a value. So this will return 3 because I've passed A on the left side and 3 on the other, and it returns whatever's on the right side, the second parameter. So I run that and I get a value back, 3, because the equals operator returns a value. This happens to set some values in memory, but I can run a different expression like 1 plus 2. This is a valid expression, and the plus sign is an operator, takes these two values and adds them and returns the result, and I can run it, and it just happens to return 3 in this case, but notice that I didn't set it equal to anything in memory. So the expression evaluated, that is to say, it ran and returned this value, this result here, but I didn't do anything with that value. But in both cases, this is an expression because it returned a value. Get that? That line of code results in a value. Now, that value could be a number or a string or an object, whatever the case, but it still ends up being a value. So I could go A equals, and I'll use an object literal greeting hi, and it still works the same way. It puts it into memory, and the equals operator returns a value. Got that? So when we're talking about a statement, on the other hand, let's say I do like an if statement. If A equals 3, and then do something. Inside the parentheses of an if statement, you put an expression because that results in a value. But the if statement itself is just a statement. It's called an if statement because it doesn't return a value. I can't say variable b equals and then if, because this just does work. No value is returned. The if is a statement, and inside the if statement you have an expression, because the expression, this triple equals, returns a value, ultimately true or false. Get that? So a statement just does work, and an expression results in a value. In JavaScript, because functions are objects, I have both function statements and function expressions, which are extraordinarily powerful. Let's show the difference. I'll clear this out. I'm going to do a function statement. I'll make a function called greet, and I'll console.log hi. This is a function statement. When it's run, when it's evaluated, it doesn't result in a value. The function is placed into memory, but it's just a statement. It doesn't return a value until the function is executed. So when I see this, it does say, okay, I'm putting the function in memory, but this unit of code doesn't result in a value. But it does do some special things. We've already seen that it gets hoisted. That is, during the creation phase of the execution context, the global execution context in this case, it's put into memory. And so it's available ahead of time. I can call greet before I declare it, before I make that function statement. So it's available to me in memory. That's fine. It's still an object. Its name is greet, and its code property contains the code you wrote inside of it. Now I'm going to use a function expression. Watch. I'll type a variable name. Let's call this anonymous greet. I'll use the equals operator. And here I could put a number or a string or an object, maybe using the object literal syntax. Instead, I'll use a function expression. I'll say function, and then I'll give myself some white space just to make it clear. And I'll make the same function. Now wait a minute, does that look strange? What are we doing? Well, remember, functions in JavaScript are objects. So I'm creating an object on the fly and setting it equal to this variable. That is, this variable, its spot in memory that it points to, its address in memory that it points to, will contain a function object. Make sense? So what's really going on here? Well, remember what happened. Let's look at our function declaration again, our function statement. This is the one that gets pulled up into memory when the execution context is created. And it has this name property and this code property that gets set. So I have an object in memory. The name is greet because that's where I put before those parentheses. And it has a line of code. And when I call it, it's connected to that spot in memory where this function object lives. And those parens then invoke the code part of the function. Now what about my function expression? In this case, I have an equals operator that's putting this object into memory and pointing that anonymous greet variable at that address. Remember, it's not really looking at the name of the function or anything like that. It knows the address in memory, just like you have an address for where you live. So we still get a function object. The JavaScript engine creates one. And in this case, I didn't have a name because I didn't put anything before the parentheses, and I don't have to because I have a variable that already knows where that object lives, so I don't need a name to reference it by. So this is an anonymous function. You may have heard that phrase. That's all this really means. An anonymous function is a function that doesn't have a name in its name property. But that's okay because you can reference it with variable names that are pointing to the address where that object lives. And we have the same code property. The same line of code is inside of there. So how do we invoke this function? We need to point at the object and then tell it to run its code. Can you guess? That's right. The variable is already pointing to where it lives, and then I put parens, which invokes the code. So if I do that here, anonymous greet, and then parentheses, and run this, that runs the same code as well. So I use an anonymous function in this case, and this right here by itself, in this case, is an expression, because it results in a value. I end up with a function object when this part of the code is evaluated or considered or executed. This is just a function statement because when the code is executing, even though this function has been placed into memory, when this part is actually run through in the execution phase, it doesn't really do anything. It just says, oh yeah, there's a function there, and keeps going. But when this line is executed, this statement results in an object being created. It returns an object, essentially. So it's an expression. It results in a value, the value being a new function object. And I can make this anonymous. You might think, well, why shouldn't I have a name there? Well, it's a lot to type. Why bother? Good code is about being clear and understandable while at the same time minimizing the amount of code that we need to write. So an anonymous function is great for this. It's very clear that I'm creating a function object, and it's not difficult to understand how to invoke it, how to call it, how to run the function. Now, that said, let me ask you a question. If I move this line above this line, just like I did for calling greet before it was created here in this statement in the code, this worked. What do you think will happen here? And why? Think about what you know about the execution context being created and then executed. Executing code line by line, knowing that it puts function statements and variables into memory first, and what it does with variables when it puts them into memory, and then how it runs line by line through the code. What do you expect to see? We already know that this will say hi because it will call this function. It's in memory. What do you think you'll see here? Uncaught type error. Undefined is not a function. Did that surprise you? Well, it shouldn't. Remember that this is hoisted, meaning when the JavaScript engine sees the word function on a new line by itself, it says, oh, you're creating a function here, and I'll put it in memory. But here it sees a variable. It puts it into memory, and what does it set the variable equal to before it starts executing the code? All variables. That's right, the special primitive called undefined. And then it begins to run the code. So it runs greet, and it says, oh yes, I have that in memory. Then it sees the function statement, nothing to do there really. And then it sees this. And it says, oh, I see that in memory, it's undefined. Because we haven't hit the line where it's set equal to anything yet. And then we just tried to invoke it as if it was a function, and JavaScript said, nope, the undefined primitive is not a function. It isn't until this line of code where it's set equal to this new function object that's created when it sees this code. So function expressions aren't hoisted. And that can confuse people, but if we think about it from the perspective of how JavaScript does this under the hood, it's not really surprising. It just only hoisted the variable. And so the variable doesn't contain an object until this line of code is run in the execution phase. So I have to then have it first set equal so that it's sitting in memory, and then I can invoke it like this. Make sense? All right, I'll put this above as well so we can see the difference. Undefined is not a function. Now when I remove it one more time, it runs just fine. Because at this point, this equals operator has been run, and it's put the result of this statement, a new function object, into this variable. That is, this variable points to a spot in memory, and inside that spot in your computer's memory is sitting this function object. All right, so let's do one more cool thing. I'm going to create a new function using a function statement called log. It'll just take a variable. let's say variable a. And I'm going to console.log whatever is passed into the function. Now I'm going to then call this function. If I pass a number, what's going to happen? Well, it'll get that number and output it. And I'm just creating this on the fly. I didn't create a variable and then pass the variable, although I could. I'm just creating that value on the fly. So when I run this, I see 3. That makes sense. What about a string? Hello. I'm just creating this string on the fly. I could set a variable and then pass that variable, but I don't have to. I can just create the string on the fly. This is a string literal. I use quotes. I could use single quotes if I wanted, and that string is created, and the function outputs it. The function got it as a parameter. What about an object? Well, we've already seen that I can use curly braces and create myself an object. So I might go greeting, hi. And it just has a single name value pair in this case, but the object is created. I could set it equal to a variable and pass that variable, but I can just create the object on the fly. So greeting, hi. But it's inside that object. The object was created. Name value pair. All right, so that's great. But remember what we just learned. A function is an object, and a function expression creates an object, a function object, on the fly. So I can do something that looks really strange. I can say function and create a function on the fly. See what I did? This works an awful lot like an object literal. I'm creating a function on the fly, putting some code. It creates that object, puts that code into that code property of that function object. It's just like a string or a number or an object. I'm just creating a function on the fly because functions are objects. And so that will get passed to the function, and look, it has the function. It's anonymous, but it's referenced with that a parameter. See how that works? First class functions. Functions that can be passed around, created on the fly, used, and variables can be set equal to them. That's pretty neat. So if I want to then invoke this function, the a parameter now points at a spot in memory where this has been created when I called the log function. It passed a function to a function, which is something you can do in JavaScript and other languages that work like JavaScript when it comes to functions. So I passed a function to a function. So now I have this a property, and it's pointing at a function object. So how do I get it to run? How can I run this function that I created and gave to log? Well, I just go parentheses, right? That tells the JavaScript engine to invoke or run the function. Take a really good look at this. I'm calling log and passing a function using a function expression, creating the function right there inside the parentheses where I'm passing it to here. And so a now is this function. It points to a spot in memory that contains this function object, and I can just tell it, okay, now invoke your code, run your code. So what am I going to see? There's that third hi. Get it? So I have a function statement hoisted into memory during the creation phase of the execution context. I have a function expression here that's used as part of the equals operator to set it equal to a variable, and then I can use that variable to invoke it. And I have a function expression that I'm passing a function as a parameter to another function, and then I can use it. This concept of first-class functions, then, where you can pass functions around, give functions to other functions. Use them like you do variables. Introduces an entirely new class of programming called functional programming. And we'll talk about that in a bit. But just for now, realize that when you see this style of syntax, it's a function expression, and it's available because of first-class functions, because functions in JavaScript are objects.